Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ajwad bin Azmi and I'm from J4EE1113B1. So for today's assignment video, I will be explain on FET DC analysis. So based on from the question that been given, this question is tell us about an N-channel D MOSFET circuit diagram. So based on the circuit been given, the configuration of the circuit is a common gate. So based from the question that we given, we need to find the drain current, which is IDQ. The next one is the DC gate source voltage, which is VGSQ. The third one is the drain source voltage VDSQ, and the last one is the terminal voltage VS and VD. So we have been given the formula to find the ID, which is ID is equivalent to IDSS in bracket 1 minus VGS over VP squared. So based on from the construction that been given, we've been given the value of IDSS, which is 6 milliampere, and VP negative 3 volt. So to answer this question, there are 5 simple steps that we need to do in order to answer this question. So first of all, we need to construct the transfer curve table. But before that, we need to find the formula for ID on each value. The next one is we need to draw the transfer curve graph based from the transfer curve table that been pointed out. And the next one is we need to perform KVL based on the circuit that been constructed in order to find our VGS and ID. That consists of VGS and ID that we get from the transfer curve graph. So the next one is we need to construct a linear graph table, and last but not least is we need to draw a linear graph in order to see the intersection point. So let's go to the first question. So based from the first question, my advice is we need to reconstruct again the circuit that been given in the question. So after so we need to short circuit all of the capacitor that been given in the circuit. So which is we need to short circuit on this capacitor which is CS, and also CI which is we need to short circuit. So the next one is we need to draw the transfer curve table, which is we need to find the VGS and ID. So we do for VGS voltage and ID milliampere. Then in order to find the value of ID, first of all we need to do our DC analysis first. So first of all, when we've been given the formula which is ID, so we need to find the ID first. So when V is equivalent to 0 volt, and therefore we can find the ID, so which is 6 milliampere. So there's go continuous until this step was repeated by using value V is equals to -1, -2, and -3. We need to find until the ID value reach 0. So move to the next question, which is after we been constructed the draw curve table, so then we can find the transfer, we can sketch the transfer curve graph. So this is the transfer curve graph based on our transfer curve table that we've been drawn, which is this. So we just need take the value until 0.0 only. So after we sketch our transfer curve graph, then we need to perform the KVL. So in order to perform a KVL, we redraw again the DC analysis circuit until become this one, which is we need to find our RTH and VTH. So RTH, where does it come from? RTH is from point where 110 mega we parallel with 10 mega ohm, which is from here, both of this one, 110 and 10 mega ohm. So after we parallel both of the resistor, we get the RTH value, which is 9.167 mega ohm. And then we need to find our VTH, which is by using VDR. So 10 mega ohm divided by 110 mega ohm plus 10 mega ohm times with Vs, which is 20 volt, and we get the value is 1.667 volt. So and then we can draw our DC analysis circuit, which is 1.667 volt, and our RTH, which is 9.167 mega ohm, and our 1.8 kilo ohm. This is our voltage source, which is 20 volt, and our 750 ohm. Okay, and then after we obtain RTH and VTH, we can proceed with our KVL at loop 1, which is here, from the VTH until the point until the ground on S, until the point ground source. So KVL at loop 1. So we perform KVL based on this circuit, this loop. So negative 1.667 plus with 9.167 mega times with 1 Ig, which is here, plus with VGS plus with 750 times with Is. So after we been calculate, and we get VGS is equal to 1.667 minus with 750 ID. And then after we perform KVL at this KVL at loop 1, we can draw our linear graph table in order to find our VGS. So when ID is equals to 0, 2, 4 and 6, so we can find our VGS based on this formula, which is 1.67 minus 750 ID, which we obtain from the KVL at loop 1. So when ID is equals to 0 milliampere, then our VGS is 1.67, followed by when ID is equals to 2 milliampere, ID is equals to 4 milliampere, and ID is equals to 6 milliampere. So after we obtain all of this value for our linear graph, then we can construct our linear graph. So and then based on our linear graph that been sketched, so the intersection point is where the value of VGS and value of ID that we obtain. So our VGS that we obtain is from the graph, which is 0.75 volt, and for our ID is 3.2 milliamp. Okay, then after we been draw our linear graph and we obtain our ID and VGS value, we continue with our second and third loop, which is second loop from V source here until this point, and for loop 3 which is from VD until ground at 20 volt. So KVL at loop 2, we need to determine the VD value. So negative 20, which is from here, plus with 1.8 KID plus with VD is equal to 0. Then therefore VD we could get 14.08 volt. So and then KVL at loop 3, we need to perform KVL at loop 3 in order to find VDS. So negative 10 plus with 1.8 KID plus with VDS plus 750 ID is equivalent to 0. Therefore, VDS we could obtain, which is 11.57 volt. Therefore, actually the value of ID is equivalent to IS. Therefore, we could find VDS is equivalent to VD. VD minus VS, or VS is equal to VD minus VDS. After we reconstruct again the equation. Therefore, VS we could obtain, which is 2.51 volt. That's all from me. Thank you.